Now for our next example of a quadratic function, where we're going to transform it into the form where we can recognize the vertex and axis of symmetry by the process of completing the square, we're going to take a look at the function y equals x squared plus 5x plus 7. And once we find the vertex, we're going to find the intercepts and then sketch the graph. So to complete the square, as you know, what we need to do is to add a constant to the x squared and x term here. So let me put a blank here to indicate that. And what I would do is right away put minus another blank to balance the equation by what we add to complete the square. So we take half the coefficient of the x term, which is 5, and that would be 5 halves. And if we square that, that will be 25/4 that we need to add to complete the square. So we'll subtract that right away to keep the equation balanced. And so now we next factor, we'll have the next plus 5/2 quantity squared, and if we combine 7 minus 25/4, that will produce then 3/4. So we can identify the vertex then to be point with coordinates -5 halves and positive 3/4. So let's next find the intercepts for the graph. And for the y-intercept, you can see that what I've done is substitute 0 for the x, and the y value then turns out to be 7. So we can say that the y-intercept will be the point 0, 7. Now if you look back at the original function, you can see that the x squared plus 5x plus 7 doesn't factor. So what we need to do to solve that for x by letting y be equal to 0 will be to substitute into the quadratic formula. So to save a bit of time, I've already done that here. And when you simplify it, if you come all the way down to the end here, we end up with the expression -5 plus or minus the square root of -3 divided by 2. Now you know that the square root of -3 is not defined in the set of real numbers. And since we're only graphing real numbers, that will tell us that there are no x-intercepts. Now, no reason to panic. All that means is we might need to find another point or two in addition to the y-intercept to sketch the graph, so we will do that next. Now what I did next was to plot the vertex, which is -2.5 and 3/4, and that is the point that I'm now highlighting in green on the bottom. And next then I plotted the y-intercept of 0, 7, which will be the next point now that I'm going to be highlighting in green up here on the y-axis. Now because this graph didn't have any x-intercepts, what I chose to do was to find another particular point on the graph, and I let x be equal to -1, and substituting in the function that gave me the y value of 3. So then we have the particular point -1, 3, which I will now highlight in green on the graph. Now what I chose to do was to use the axis of symmetry then to find the partners to each of those points, if you will, because the points that we now have are to the right of the axis of symmetry. So I'll locate their partners to the left of the axis of symmetry. So for the point -1, 3, its partner will be located right there, and the partner to the y-intercept will be the point up here to the left of the axis of symmetry. So now if I then connect those 5 points in a smooth continuous curve, then we have the graph of the function.